Let's take a look inside that Rivera-Era Fender concert. The owner thought it was 1982. The transformer here has a date code of 84. And I think these first came out on the market in 83. So I'm pretty sure this is an 84. So let's see what's under the doghouse cover. It's got all the original iron, and yeah, all the transformer codes do indicate 84. So the amp's at 84 or 85. All right, let's see here. It's been recapped in its life. That's good. Got this one original cap. I don't understand people who do all the caps but one. And as you'll see in a moment when I call up the schematic, it's got some odd choices, some of which I will be revisiting. But even though this has been recapped, it looks like these caps are from 2002, so it may be time to do it again. This one original cap here might be explaining that graininess that both channels have that was really apparent in the overdrive, that clipped square wave, like a misbiased fuzz pedal. So I'm going to come back to this in a little while. Let's see what's on the other side. Fairly standard for the Rivera-Era. It's got a whole bunch of great big resistors dropping voltages in odd ways, which aren't inherently problematic, but I do find that it makes for a very constricted, kind of clinical feel. Got these great big orange drops everywhere. Let's see which series these are. Pardon me, I can't see through the lens as I do this. Looks like they're 418. That's a good polyester. It's been recapped for the most part when the whole thing was done, except for these two, which again could be contributing to that graininess. It's not the only factor though. The circuit is all kinds of crazy. But the good news for making changes is that the pots are all real pots, so nothing's tied to a circuit board. And I can get in there and replace things as I need to. And a couple places I know I need to. Now, I'm going to put the original schematic up here on the screen right now. And I'm not going to go too far into what the minutia of that is, because as you can see, it's a fairly confusing schematic the way it's laid out. In a nutshell, it has a very standard Fender circuit for the clean channel. The V1A is run in parallel, and the output of that feeds both channel tone stacks. On this channel, it's a Fender tone stack, then it goes to a really nasty sounding bright circuit before it goes to the volume. And after the volume, there's a mute point, and then it goes to the V2B, which is the second gain stage for the clean channel, which is pretty much what you'd find in any 60s Fender. And then from out of there, it goes to an optocoupler, which is working as a switch to select which channel is feeding a fairly standard Fender reverb with some mistakes in the cathode and a little too much low end feeding the reverb. And then to a loop, which is bypassed when it's not used. And I'll make sure that when it is used, it's quiet and works well. Then to the phase inverter, which is pretty much what you'd find in a 1960 Bassman, only using an AT7. Might benefit from doubling it a little bit more with an AX. We'll see what the gain is like once I do everything else. The only thing that's really not standard in the PI is that the input cap is 100 nanofarad, which can be kind of woofy, especially with the 30% tapers on the bass pots in this amp. And it's got 330K grid leaks, which are fine, but are going to be even worse with the total lack of headroom. going on in the thing. So I may keep those 330K. I may bump those up a little bit. The standard 1 meg is actually pretty much overkill because it's bootstrapped. It gives a really high input impedance. Even 330K is fairly high. I'll play around with that. What I just showed you is this more simplified version of the schematic. So you can see the clean channel, the fairly standard Fender tone stack, bad bright circuit, volume with a mute, next stage, and then selecting to the reverb, then the loop, and PI. And I didn't draw out the reverb circuit because it works pretty much the same as it does in an AB763. Just has some dumb values. I'll look more closely at the loop, and then goes to the phase inverter like I discussed. I didn't draw the output tubes because that's, bone stock for most Fenders. All right, on the dirty channel, it has, again, the same Fender tone stack with a 30% volume bass pot. Only difference between this tone stack and this tone stack, it has that mid boost, which just puts a cap in parallel with the 250 picofarad bright cap. I think it's a little bit overkill the way they did it. I'll look at that. And then instead of this one has just a 6.8K to ground for the mids resistor. This one's got a 10K pot. I'll probably be changing all three pots on this channel to voice it differently. And I might move the tone stack to a later place. This topology will certainly change on the dirty channel. So we have this V1, which is parallel on the input with unbypassed. That's not the best, unbypassed cathode, not the best sound there. Then it goes to the volume after the tone stack. There's a mute point there. Goes to a high gain, warm biased, full range tube stage. And then the output of that goes to a 3 meg pot, reverse audio. That's the volume, that's the gain. That's an insane value to use. It's just a guarantee of large noise. You get a huge range of volume increase with that 3 meg, but you got to scale these things for lower noise. And after that, it goes to another full gain, full frequency stage. So you got a full gain, not quite as much with the unbypassed. Full gain, that's just a recipe for bad clipping, and you're hearing that. So this whole topology is going to be changed. And the output of that goes to master volume, and that master volume is just feeding that other optocoupler that's working as a switch. So I'm going to sit down and figure out whether I want to do this more like a Marshall or Tweed Bassman, or more of a Dumble thing. Now a Dumble would just take the output of this channel and then run it to here, to this volume adjustment, or a gain adjustment, however you want to think of it, then to a different gain adjustment, and then to a tone stack and a master volume. So the tone stack would be here. So basically you have the clean, and however you set the clean, then feeds to the overdrive, and you attenuate that as necessary so you don't clip this stage. Then you add gain with the next stage, and then you have a tone stack to make up for, you say, you set this for a great clean, well, that introduces problems for your overdrive sound, so you then EQ to compensate for the choices made here. And then the output of the master volume would also be switched here. A little more complicated switching, but not much. And I could do that, but I actually have a problem with the way Dumble does that, in that you're making tonal decisions for the clean channel, and then those, you have to compensate for those. And on most Dumbles, that second tone stack is internal or fixed from the player's perspective. It's a set and forget kind of thing you can't really access easily. I think this might be better to do a totally separate independent channel. So this tone stack is not compensating for this. It's voicing specifically for what's actually happening here in this whole channel. I've got 3 gain stages here, and there's an unused triode in the amp, so I could have 4 as necessary. I don't think that will be necessary. The other thing I want to look at, I do some calculations, is they're running V1 as a 12x7 parallel with unbypassed cathode. It might be beneficial for our purposes to split the input, to separate these triodes out. So instead of one shared plate resistor and unbypassed cathode, I could do individual plate resistors, individual cathodes, and tweak the low end differently for the overdrive channel versus the clean channel, and only have the inputs shared, which is more like you'd find on a lot of more vintage amps. That's my inclination. When you have this tube in parallel, you do get additional current driving, so this tone stack does not load down these, because these loads here for tone stack to volume are in parallel with each other. They add up. And offsets with that. I think that at the end of the day, the difference between one tone stack hung on an individual plate and the other tone stack hung on the other individual plate with separate cathode circuits is probably going to be theoretically not as good as having this in parallel, but in reality, I think that the ability to tweak the cathode for the gain stage will offset that and will give a better thing. I got to look at how I can make it work on the physical layout of the board. But I can go into minutia on this kind of thing. But in general, the input impedance of two triodes is high enough that the guitar is not going to get dark running into to both grids of independently wired triodes here. But it gives me more tonal flexibility, and there's so much makeup gain available here that whatever I might nominally lose there, I can get back. But I don't want to have hot bias in a row. I want to cool one of these bias stages. And I might, since I have an extra triode, I could make one of these a cathode follower, which does drive a tone stack in a different way and can affect the feel. A plate-driven tone stack can be a little bit stiff, which is fine when you're clean, but it can be a little bit on the harsher side for overdriven stuff. So I've got some decisions to make. And so this is what's happening in the stock amp. I know that most of the problems are here. A few problems in the reverb circuit, some improvements to make to the phase inverter circuit, and I'll look at the loop. But the architecture of the gain stage is what I need to play around with, and I've got to look at how the board is laid out very closely to be sure. Ignore this stuff. This is SVT stuff and some orders I've placed for parts from various vendors. Yeah, various vendors, not various fenders. Anyway, there's nothing I see here that scares me off from this, but I will tell you that this 3 meg gain pot is going to go away because that's just insane. I forgot to show the weirdness that is the power supply in terms of the filter caps. Right after the choke, you see that next node, the 20 microfarad in series with the 70 microfarad. That's the screen supply, and they've got a 500 volt 20 microfarad and a 100 volt 70 microfarad. And that whole thing is trusting in that 120K resistor and that 22K resistor, sorry, misread that there, 22K resistor to protect that 100 volt cap. That is just all kinds of crazy. Because if that one half watt 22K resistor fails, there's no guarantee that that 70 microfarad cap's only going to see 100 volts. So I'm going to measure what the actual voltage unloaded there is. If it exceeds 500 volts, then I'm going to do that 2070 more properly to be probably 247 microfarad 500 volt caps with 100K or 220K voltage balance resistors. Then you got a 10 watt 2.7K dropper, which would normally be crazy in terms of the wattage, but they got that 30K 20 watt to ground in parallel with the next filter cap, which is the phase inverter supply. That's a weird thing from this era of Fender. I may do away with that and just play around with what the decoupling values are, and then that 4 microfarad cap for the E stage, which is the one that on the preamps use. That's just almost doing nothing. It's a stupid small amount of filtering, and that might also be contributing to the graininess. But we'll get back to that. Okay, and I figured out my game plan for this amp. I'm gonna run this by the owner before I do all the big design work. But working with the existing topology of the amp, compare earlier in this video, and making use of the unused V4B in the existing amp. My plan is to have a 2.5 channel amp out of this. So the foot switch will select between channel 1 and channel 2. Channel 1 will be pretty much a straight normal channel from a Fender, either the super reverb or the twin reverb. So nothing earth-shattering there, just a very good Fender clean without reverb. And that channel 1 can possibly feed the rest of the amp. The signal will be going from the input jack to V1B with a separate plate and cathode where I can trim all the values I want, which will then feed a Dumble-esque tone stack with its channel volume, which is for the cleans primarily, and then to V2A. And at that point, you can either have the clean output of this feed for channel 2, feed the rest of the amp. So you have two different clean settings. And even in clean, this can be a little bit overdriven. Or this mode, this channel has a dirty mode, which will be selected by the push-pull on the front panel. And if it's dirty, it's going to go to a Dumble-esque overdrive circuit without the compensating master volume. Compensating tone section. And I'm just going to voice this very carefully to work with however you set this, which means that if you're using this for clean, you can voice this optimally for the clean. If you're using this for the overdrive, you can voice the tone stack optimally for that. And when you're in overdrive mode, this channel will have a master volume. And so either the clean or the overdriven version of channel 2 feeds the rest of the amp. Now, in the studio, you can use all three. But for live switching with the foot switch, channel 2 will either have to be clean or dirty. So you have clean here, and then clean or dirty you can switch between. I think that will be the best use of all the front panel options. Means that I have a lot of leeway to really voice this right. The guy loves Robin Ford. I've spoken to him. He likes the Thin Blue Line era stuff. Spoke to my friend Yellow Welligan, who knows his Dumbles. And based on which amp he had at the time, this should do the trick very well. I'm not going to share any of the particulars of what I do on this because some of it will be secret squirrel stuff. But this as an overview should get me there in terms of the topology. Now, some of these cathodes may end up not being bypassed. I've shown the bypass caps there. And since V4B is not used in the stock amp, I'm going to have to look at what I've got here to work with on the board. But I've done some sneaky things in the past. I think I can get away with this. So I think this will be a cool amp. And the thing I've not shown here that I've got to take into consideration is the filtering, where each note is filtered and how it's filtered. I may need to separate this channel from the preamp with a different filter node, but there's plenty of room to do that. So a lot goes into amp design. This is going to be a lot more work than this quick sketch, but I know that this quick sketch is one way to get a really good versatile and musical amp out of this dog's dinner that came in. So let me put this video up and send the owner a link, and he'll know my thinkings, and then we'll talk and see if he agrees that this is a good path. This uses all the existing front panel controls. Nothing gets relabeled. The only change is that the channel changing will only be done by foot switch, but channel 2, the Dumble channel, let's call it that, can be either in clean mode or dirty mode, and the master volume is only in effect when you're in dirty mode. I think that's the way forward.